Can you talk about the benefits customers see by having the digital product versus having, say, a more traditional analog solution? So whether it's design, startup, production, any of those phases.
Yeah. So like I was explaining earlier, our products, since they are digital, so they're so flexible. Like, so if the designer has to change anything, he doesn't have to go physically change a resistor or a capacitor. So we offer so many the register settings. So, and we have, during the development process, we have a GUI that the customer can hook it up to a PC.
Mm-hmm.
And then while, if he needs to like optimize something, tweak something, just he needs to go to the GUI and then change a couple of register settings,
mm-hmm.
and it is done.
Can you have like a specific thing that they're trying to optimize for or change that you've come across that?
Yeah, for example, like if the designer is looking for a sweet spot, frequency versus
mm-hmm.
efficiency, let us say.
Okay.
So the frequency, we can change through a GUI,
mm-hmm.
and then take a measurement of efficiency. And then the another piece is the transient response. These are all kind of interlinked. If you change something, then something else will change. But if it is done the traditional way, then it is a lot of work to change the components and all of that. So as opposed to that, we can change the register settings and then take a measurement there and then change it again
mm-hmm.
and take another measurement. And then you get all this data and then you compare and then you find your sweet spot
mm-hmm.
of best efficiency, best transient response at the desired frequency.
And even some of the software, there are some automated, I think, profiles or automated ways of testing these types of situations.
Yeah, it's possible.
So you can have the system actually check all of these, a lot of parameters, and see what the responses are too.
Absolutely. Yeah, actually, you bring up a good point, Dean. So these are digital controllers. They are real time. The controller, driver mouse together. They are monitoring all sorts of things like the cycle by cycle current sensing and temperature sensing and all of that. And then the controller is always talking to the system, CPU or SoC. So they get the real-time monitoring and then real-time, like if anything has to change on the fly,
mm-hmm.
They can implement that too.
Yeah.
Yeah.
Yeah, that's an amazing solution.
Yeah.
How about you? Can you explain what differentiates our products from the solutions that are available now on the market?
Yeah, the differentiation is our digital controllers, multi-phase digital controllers, having that flexibility as I was explaining
mm-hmm.
earlier.
Yeah.
And then the driver MOS being a monolithic driver MOS, you can get the smallest package size, which lends itself to a small solution size. Like the PCB real estate is a premium in any application, and it applies to the automotive applications as well. So our driver MOS can save driver MOS, and then our performance, like transient performance, our technology can enable to use fewer output capacitors. So that overall saves, cuts down the, let us say we have done competitive analysis in some cases where we saw up to 50% savings in number of components versus the traditional solutions, and up to 20% PCB size reduction using our products compared to traditional solutions.